Greetings, mathematicians. Today we're going to be learning about standard deviation, which is the average amount either above or below the mean by which the data deviate from the mean. All of these symbols, you've seen some of these before, the equal sign, the square root sign, the fraction bar, x, n, parentheses squared, all of that. What may be new would be this lowercase s here. Well, this s actually stands for sample standard deviation. And in statistics, there is a sample standard deviation and a population standard deviation. Because the numbers we're working with are so small, we are going to be working with the formula for sample standard deviation. The only difference is in population, it's the same formula, but in the denominator, it's just n. But for here, let's go ahead and move on. The next symbol that is new for most students is going to be it's actually the Greek letter sigma, and it stands for summation, which means to sum or just to add it up. That's pretty much what summation means there. X itself, x is an individual data point. And x bar is the mean, or the average. And the last variable here is n, and n represents the number of data points, the total number. Let's go ahead and put total number of data points. Alright, so let's go ahead and take a look at what these are, how we calculate the mean and standard deviation. First of all, the mean is add up all the numbers and divide by the number of numbers. Both of these, we're actually going to call this set A, and we're going to call this one over here set B. Well, not D, but B. And if you were to add all of these up, they would add up to 50. Divide it by 10, and we get an x bar of 5. Set B, if you were to add them all up, they would add up to 50. Divided by 10, x bar is 5. The mean, the average for both sets is 5. However, what we're going to be doing is finding the standard deviation, and we need to know the mean. We also need to know the number of items, so it's 10 items for both of these. The number is 10. And now what we're going to do is look at the first row of each column here. The first column is x. The second column in parentheses is x minus x bar in parentheses. So x, the data point minus the average. And then this is going to be almost identical, x minus x bar in parentheses squared. And we'll do the same thing over here for set B. X, and then in parentheses x minus x bar, and then in parentheses x minus x bar squared. So again, data point, this is going to be the difference from the mean, and this is going to be the difference from the mean squared. So my points are already in order, 2, 2, 3, 3, 5, 5, 6, 6, 9, 9. So in parentheses, I would have 2 minus 5, well that's negative 3. In parentheses, another 2 minus 5, negative 3. In parentheses, 3 minus 5, negative 3. And I'm actually just going to fill out the table. I'm going to go ahead and do that for both. Alright, so both of the second columns have been filled out for both. And again, following the same pattern, the data point minus the average for each of these. And again, in parentheses, this is what the value would be. And now we need to look at the last column, which is the same value, but it's squared. And notice it's in parentheses, and that matters because when a number is in parentheses, especially if it's a negative number and it's in parentheses squared, the answer is always positive. So negative 3 squared is positive 9. And then we'll just fill in these values. Let's just fill in these values quickly. So 9, 9, followed by, and actually that's a typo, those should be negative 2's right there, followed by 4 and another 4, 0 squared is 0, 0 squared is 0, 1 squared is 1, 1 squared is 1, 16 and 16. So that takes care of that one there. Let's go ahead and do the other side here. So negative 2 would be in parentheses squared. Negative 2 times negative 2 is positive 4. Follow that. The next one, negative 1 in parentheses squared, is positive 1. So we're going to fill in that table really quickly, real fast. Alright, so the table's already been completed for the first, second, and third columns. Now we actually need this numerator in the fraction in the square root symbol here. We need the sum of all of the differences from the mean squared, which means add up all of these numbers here. So these numbers add up to 60. Over here on this side, the sum of the differences from the mean squared is equal to 12. Add up all those numbers, you get 12. So now I have enough to follow the formula for both of these. So the formula is, again, S equals, standard deviation is equal to the sum of x minus x bar squared, the difference from the mean squared, divided by n minus 1. So on this side, this standard deviation is going to equal 12 in the numerator, divided by n is 10, and n 10 minus 1 gives us 9. So this is what should go in the calculator. Over here on this side, it would be S standard deviation equals the sum of the differences from the mean squared, 60, and again, 10 numbers, 10 minus 1, 9. So if we did the let's do the one over here. So the square root of 60 divided by 9, that's going to give us a standard deviation, rounded of course to 2 decimal places, of 2.58. And over here on this side, the square root of 12 divided by 9, that's going to give us a standard deviation of 1.15 when you're rounding to the second, the hundredths place, 2 places. So now that both of them have been calculated, this is a good time to talk about standard deviation, and especially when you're comparing the 2 lists of data. The smaller the standard deviation, the closer the numbers are to the mean of the data. So 2.58 is larger, and so the numbers are farther away from the average here than they are from the 1.15. So standard deviation talks about, on average, how far away is data from the average of the data. All right.